Okay, here's the front. Now, I'm not going to take the time to go through all of these. We should have talked about some of them in class, especially this one and that one. If you don't understand how I set up these equations, I tried to give you the rule that I used on each one of these. So this segment plus that segment equals the entire segment. That's the segment addition postulate. Over here, we've got a midpoint, and a midpoint cuts a line segment into two congruent line segments. So that's the definition of a midpoint. So x squared should equal 2x plus 35, and then you solve it like a quadratic. Here are the answers to 4, 5, and 6. Pause the video if you need to write some of them down. Okay, let's go through the constructions on the back. So, I've got these two angles. I need to somehow find 3/2 of angle R. That's this one. And I need to find 1/4 of angle A. Let's find 1/4 of angle A first. So to find 1/4 of angle A, first I need to cut it in half, and then cut the half of it in half again. So to cut an angle in half first, I'm going to make a big arc across it. That's the Cyclops frown at any arbitrary length. And now I need to poke out the Cyclops' eye. So to do this, I'm going to have to extend my compass long enough that the arc made from this point and from this point will actually cross each other. So from this point right here, I'm going to make an arc. And from this point right here, I'm going to make another arc. Wherever they cross, this point is going to tell me where to draw the bisector ray. So the bisector ray would go right through here. Okay. Now, that's half of angle A. I want to get 1/4 of angle A, so I'm going to cut half of it in half. So I'm going to do the same process on this angle right here. So again, I'm just using some arbitrary length to draw this first arc. Now I'm going to use some other arbitrary length to draw the next two arcs. So they have to be the same length from this point and then from that point right there. And really I could have used this original arc that I drew and done the same thing from those two intersections. So this gives me half of angle A, which would be 1/4. So the measure of, let me name this, let's say letters that I'm not going to use elsewhere. What about B and C? Okay. So the measure of angle BAC equals 1/4 of the measure of angle A. It's 1/4 as big. Okay. So there's one angle that I need. And what I'm going to do is copy that angle down here. So when I copy an angle first, I just want a ray. I'll call this, because the angle I'm trying to draw is called JDN, this would be the vertex point D, and somewhere down here is going to be point N. Now, where's point J? Well, that I've got to find out. So first I'm going to copy 1/4 of angle A onto this ray. So to do that, again I need to pick some length. And draw an arc across it. And draw an arc of the same length over here. Okay. Now I need to measure the width across on the same arc that I used right there. Just a little bit. I want to make sure I get an accurate reading here. And then that same width over here. Okay. So this right here is an angle that has measurements of, let me try this. I'll just say this angle right here is 1/4 the measure of angle. There we go. Okay, now to that I need to add 3 halves, or 1 1/2 the measure of angle R. So there are a couple of different ways I can do that. But to do either one, I need to cut angle R in half. So this is 1 1/2 angle R. So I'm going to add angle R, and then I'm going to add half of angle R. So let me find half of angle R first. There's an arc. Now poke out the Cyclops' eye. There. And there. Okay. So this is half of the measure of angle R. Right here. So first, I'm going to copy angle R, which would be 1 angle R, and then I'm going to add another half. So I'm going to copy essentially 1 1/2 angle R. So first I'm going to copy angle R, like I said. Right. There's an arc, and there is a matching arc. Now I measure the width across it. There's the width across it. There's the width across it. Okay. Now I missed my mark a little bit. Let me go back. I can still see it right there. And draw that again. Okay. So this is the measure of angle R right here. I need to add another half of angle R to make 1 1/2 angle R. So I'm going to add on half of angle R. So again, I'm going to make an arc. Measure its width. Oh, see, I did this in the wrong order, because I have to have an arc that's the same as the arc that I just made on my other angle. So there's an arc. Now I've got to draw an arc of the same radius over here. Now I'm going to measure the width. Now I'm going to measure the width. Oh, wrong width. I want to measure half of that width, don't I? Yeah. Okay, so there's half of angle R, so there would be half of angle R right there. I'll call this point J. That way I have angle JE. So this is 1/2 the measure of angle R right here. So there's 1/4 of angle A, and there's angle R and another half of angle R. So 1 1/2 angle R. And all of these added together by the segment addition postulate should equal 1 1/2 angle R plus 1/4 angle R. Okay. Number 8. We need to find 5/8 of this angle, and then copy it onto another line. So, first what I need to do to find 1/8 of this angle, well, first I need to find 1/4 of that angle. But to do that, first I need to find 1/2 of the angle. So I'm going to first cut this line segment in half. So to do that, I'm going to make 2 arcs, one from each end, that are more than halfway across. I'm drawing, this is the 2-sided dish. So there's one, and there's the other. Now, going to carefully connect these 2 points. And I have cut, I call this M for midpoint, I have cut this line segment in half. Now, where would 5/8 be? Well, it's going to be a little bit more than half. So, to make this easier for me, I'm going to cut this line segment in half right here, rather than this one. So, again, more than halfway across the line segment that I'm trying to cut in half. I'm bisecting MD now. Okay, there's my smaller two-sided fish. So I'm going to call this point Q. So that's like the quarter right there. So this is 1/4, this is 1/4 of the original line. If I measured from C to Q, that would be 3/4 of the original line. Okay, now 5/8. I'll say this is 1/2 right here. This is 3/4 of the original line. 5/8 would be halfway between 1/2 and 3/4. It's the midpoint of 1/2 and 3/4. So I'm going to cut those in half again. Another two-sided fish. Connect those, and this point right here, which I'll call E, should be 5/8 of the distance of the original line from C. Or in other words, the measure of, sorry, it's not here, I can measure the line segment. Let's say CE is 5/8 the measure of CD. Now, I don't want to just find the length that's 5/8 from CD, but I want to construct a line segment. So, basically what I want to do is copy the length of CE onto a new line segment, one that I'll call AB. So first I'm going to draw a line, and let's say A is right here. So where's B going to be? Well, to figure out where it is, I'm going to steal the length of line segment CE, because I want this line segment to have that same length as CE. So to do that, I'm going to use my compass right there. Make a mark of the same length. And where that arc crosses this line, I'm going to call that B. So this line segment, AB, has a measure that is 5/8 the measure of CE, which is what I want. So here's my line segment AB. A couple of things I want to point out. First off, I want you to notice that the arcs that I drew are neat. They actually look like parts of circles, instead of what I saw in some of your quizzes, which were scribbly looking things that sort of looked like you just drew them with a pencil like that to make them look like arcs instead of drawing them with a compass. You need to actually use a compass. Also, some of you tried to measure stuff with a ruler. That's not how you construct. There should be no measuring involved either with a ruler or with a protractor. All of this is happening with only a compass and a straight edge.